All right, these are the parts of the review for the final that we have not gone over. 2A, you have actually done this section. So 2A, you'll want to fast forward through 5.5. And I'm only doing the video for the part that we would do as a class. You are still should try to do the on your own, okay? All right, so going up here, operations with functions. So the idea is that if these two functions, one of them is f of x, which is 2x minus 3. The other one is x squared minus 1. And I'm going to put them together by adding, subtracting, multiplying, dividing, etc. So in the first one, I'm to add the two functions. When we did this, we always put them in parentheses. Sometimes you need the parentheses and sometimes you don't. In this case, I don't really need the parentheses, but the idea is to clean this up and have it in standard form, which means no parentheses, just all addition or subtraction. Okay, so here I just have to combine like terms. And then the other thing that's going to happen is that in standard form, if this is the multiple choice part, you need to write your answer from highest power to lowest power. So I'm going to start with x squared. There's nothing to combine with x squared, then the 2x. But now what's going to happen is I'm going to combine these like terms here. And maybe it's helpful if you add the opposite, but that becomes -4. So when I'm done, my answer is in standard form, this. So on the second one, I'm going to subtract them, so I will wrap them in parentheses. And here the parentheses are important because there's a lot of subtraction, especially at the end, because you're not just subtracting x squared, you're subtracting everything in the parentheses. So this is where I started getting on your cases about adding the opposite and to go left to right, not to jump around, you know, from the beginning to the middle to the end. So, well, that is the beginning, the middle to the end. That is left to right. So anyway, I'm going to go left to right, add the opposite. So I'm going to add the opposite here. And when I add the opposite with the subtraction to the parentheses, since the subtraction applies to all of the parentheses, when I add, I'm going to take the opposite here and here. So now when I combine my like terms, my leading term will be -x squared plus 2x, and then when I combine just the numbers at the end, I will get -2. All right, on the next one, I'm going to multiply these. All right, I had to pause the video there for a second. So C, we are going to multiply these. So again, wrap them in parentheses. And we will be distributing. So I'm going to start with the 2x, and I'm going to get 2x cubed. Remember, when we're multiplying and the bases are the same, like they are with these x's, you add the exponents. And then I'll get a -2x. And now the -3 is going to distribute. I'm going to get a -3x squared, and then a +3. And again, on the multiple choice, this answer would be in standard form. So it would be 2x cubed, then the -3x squared, then the -2x, and the 3. So D is very similar to the section that we've just did. I'm going to set these up, and since it's a fraction, we look to see if we can simplify the fraction. And you look to simplify with common factors. So 2x minus 3 does not factor, but x squared minus 1 does. It is a difference of squares, so it can turn into x plus 1 and x minus 1. And even after that, there is no common factor from the top and the bottom. You can't take out, for instance, you know, this x with this x, because those are terms or parts of terms. So you need to leave the x's intact, and that is your answer. So E and F started to be some new stuff for you guys. These were called composite or composition functions, and it meant you took one function and put it into the other function. So when you see E, this means I'm going to take G's function, so moving back to the top, G's function up here, and I'm going to put it into F's function, and I'll put it into the x. So G is going to go into F. So when I start to rewrite f of x, the 2x minus 3, I'll still have the 2, but the x is gone, and now I have x squared minus 1. And then I still have the minus 3. So I'll distribute, get 2x squared minus 2, then I still have the minus 3. And then when I combine like terms, I get 2x squared minus 5. So the other way means that F is going to go into G. So this time what will happen is all of F will go to where into G, and it will go into its particular x. So normally x is squared, so now what's going to happen is 2x minus 3 is going to be squared, and then we still have the minus 1. And remember, that squared means that there are 2 of these. And so I will have, as I tell my freshmen, the neighbors meeting the neighbors. So starting to distribute, I'll get 4x squared minus 6x. Then the negative 3 will distribute. I'll get another negative 6x and then a positive 9. And then I'm going to go ahead and bring that minus 1 to join the 9, just combine these like terms. And so when you're done with f, you get 4x squared minus 12x plus 8. This is your answer. Don't try to factor anything like that. If you start to factor, you're going to get back to what you started with, and that's not what we're doing. We're trying to make one function in its original format. So don't factor it. That one's done. So with g and h, what's going to happen is what this means, and it is missing a parentheses at the end, is that 2 needs to go into g's function, and then once you get that all needs to go into f's function. So there's 2 ways you could go about it. One is, just moving back to the top, is I could put 2 into here, get that number, and then take that number and put it into here. But if you notice, on E, we already took G and put it into F. We've already done this part. So what I could do is just take the 2 and put it into there and have 2 times 2 squared minus 5. And then just follow the order of operations. So first I would do the exponent, that's 4. And then 4 times 2 is 8. And then 8 take away 5, my answer would be 3. And then at H, what they want me to do is, going back to the top, is to put 4 into here and 3 into here, and then since it's a fraction, just try to simplify it. So if you notice, we kind of already did that here. We put f of x and g of x together, so I'm just going to put 4 in the top, so 2 times 4 minus 3, and I'm going to put 3 in the bottom, so 3 squared minus 1, and then just follow the order of operations. So for the numerator, 4 times 2 is 8, and that 8 take away 3 is 5, and then in the denominator, 3 squared is 9, and 9 take away 1 is 8. And then as a fraction, 5/8 cannot be simplified. And then in chapter 5, we started to see inverses, so just reminding you of that because that'll be coming up in its own particular section. The big step of inverses is to, first, this is y, but the first step is to switch x and y around. And now your job is to get this y by itself. You're just solving, and you could think of it as a regular y. There's just one of them. So you're going to make your little checklist to get that y by itself. So the first thing I'm going to do is move the 7. I'm going to subtract 7. So on the left side, we have x minus 7. On the right side, we still have the 3 with the y minus 2 cubed. The next thing I'm going to move is my multiplication or division. I'm going to divide by 3. So now on the left side, we have x minus 7 over 3 equals the y minus 2 cubed. And now I'll get rid of the exponents. I'll cube root both sides. So when I cube root this side, that takes out the y minus, or the cube, so you have y minus 2. And then I'll cube root this whole side. So just make sure you put that whole thing in the check mark. And now it's not parentheses, but basically what's left is to get the 3 to the other side. And when I move it to the other side, it will not be in the cube root. The cube root is done. It's this, but I will just add 3 off to the side. And this is the inverse. Okay? So now what you're going to do is go to the on your own and go through those. I do have the answers, so you can check with me as you go through. All right? All right, so with that, what I'm going to do is go into 5.6 and go over finding the inverses. So this is just more of these. My job is to, on all of these, switch x and y around and then to get those y's by itself. So again, these are all y's. And the first step of inverses is to switch x and y around. And I'm going to make my checklist. Now, on 2 of these, the checklist is going to be a little different, or I'm going to throw one more thing in there because of how the x is placed in the problem. But in my first one, what I'm going to do is just work to get that y by itself. I'm going to make my little checklist. And the first thing I'm going to do is move this 3. I'm going to add 3. So on the left side, I have x plus 3. On the right side, I have 1/2 with this cube root. So I moved my addition subtraction. Now I'm going to get rid of the half, which is multiplying to that cube root. And so to get rid of a fraction, I just multiply it by the reciprocal. So I'm going to multiply by 2. And those go away. And I'm going to multiply this side by 2, all of it by 2. So what I can do is go ahead and just distribute that 2 in and make it, I'm going to move over, well, 2x plus 6 equals this cube root. And now to get y by itself, to undo the cube root, I'm going to cube both sides. So I'm going to cube the cube root, and that gets rid of the cube root, and I'm going to cube this whole side. And I'm just going to leave it like that. I'm not going to take 2x plus 6 and multiply it 3 times. But now to get y by itself, I'm just going to move the 2 over by subtracting, and this is your inverse. Okay. All right, number 2, a little bit simpler. It's just a regular x. I'm going to make my little checklist. And the first thing to get y by itself is subtract 3. So on the left side, I'm actually going to put it here. I have y minus 3 equaling 2x. Oh, sorry, let's back up. I did not rewrite the problem. So that's the y. And now I'm going to switch x and y around. So x equals 2y plus 3. All right, so still subtract 3. So on the left side, I have x minus 3 equaling 2y. So I move the addition subtraction, and now I'm going to move the 2 that's multiplied. I'm going to divide it. And you can just write your answer as y equals, you can put x minus 3. All of that is dividing 2. So 3 and 4 are a little different because your x's are weird, as we've used in the past. So to get to them, I'll have to think about what their opposites are. So first, I'm just going to go ahead and switch x and y around. And starting to get y alone, the first thing I'm going to move is that fraction. They divided by 3, so what I'll do is multiply by 3. So multiply by 3 here. It's gone. Multiply the other side by 3. So now I have 3x equals 4 to the y minus 3. Now, I won't divide by 4 because 4 is not multiplying to y minus 3. It's the base of the exponent. So to get to the exponent, what I'll do is its opposite, and the opposite of an exponent is a log. And it was better to do the log when it was switched to this side. So here goes the log. I'll do log 4. So log 4 of 3x, and that will equal y minus 3. And now to get the y by itself, just add the 3 over. And this is it. Now, if you want to be on the safe side, the only part of the log is the 3x. So if you want to wrap that in parentheses, you can, but don't put the 3 in the parentheses. That's not part of the log. And the last one, I'm going to switch x and y around. There is a base to this log. It's an understood 10. And so, to get to that y, it's part of the log. So I will have to undo the log, which means I'll turn it into an exponent. And we're used to having it like this when we turn it into an exponent. So now I'm going to turn it into the exponent. So 10 to the x power equals y minus 3. And now to get y by itself, I'm just going to add 3. And here's your inverse, 10 to the x power plus 3. It's not part of the exponent. It's normal sized, equals y. So now what you're going to do are the next 4 problems.